So you have heard it time and again now throughout this course. Hazard recognition is really one of the most difficult parts of hazard analysis. It's the hazards that lie hidden or dormant. They're the ones that can really cause a lot of damage. I've heard it said that it isn't the hard hit that knocks a good manager down. It's the one that he or she doesn't see coming. It's the same with hazards. A quote first penned by Wilbur Wright in a letter to his dad in 1901 has become quite popular today. Carelessness and overconfidence are more dangerous than deliberately accepted risks. If we don't know the hazard is there, we cannot deliberately weigh and accept or reject the risk. As you go through this material in this course, I hope that you begin to view life through a different lens. As you walk across campus, eat in the cafeteria, walk into your home, or walk into a classroom, I hope you begin to really recognize hazards like you never have before. I hope you see the hazard components, the hazard source, the initiating mechanism, and the TTO. I hope you see those components in everyday life. The hazard triangle, I hope you visualize it as you're walking, going about your day. Through this part of the presentation, we're going to be just looking at hazard recognition, not mitigation. Just those things that will help us to recognize the hazard. These are strategies to identify hazards. We will drill down briefly on 3 perspectives, all designed to help us look at our system through a different lens, to help us more thoroughly and systemically identify the hazards. So we're going to look at the system perspective, the failure perspective, and then different hazard recognition factors. The system perspective helps us look at the higher level system and interfaces throughout the system and subsystems, helps us root out hazards through these elements. From a physical perspective, we understand the system's hierarchy, construction, and how the elements of the system interface with one another. We ask the question, how's the system built? How do the parts interface with one another, and how might that generate hazards? From the functional perspective, we look at what is the system supposed to do? What inputs do the system require? And what outputs or transformations do we require of the system? How might that process generate hazards? From the operational perspective, we look at the system from the perspective of the user. Where will the user be when they're operating the system, and how will they interface with the system? How might that generate hazards? From the software perspective, what software is integrated with the system, and how might a software failure, sneak circuit analysis, that kind of thing, cause system hazards? From the environmental perspective, we look at the internal and external environment in which the system has to work. To what hazards? What heat, fuel, natural disasters, etc. What hazards are around the system or circulating? To what hazards is the system prone? From the human perspective, we look at the human interfaces with the system and how human error might impact the safety of the system. The human is the most prone to error. To err is human. When the human messes up, what hazards might be generated from that? From the organizational perspective, what managerial factors might be setting the system up for failure? In a previous company that I worked for, we had an operation that carried 2,000 pounds of perishable cargo. It was valued at many thousands of dollars, and we carried that cargo throughout Latin America. If a pilot had to cancel a flight due to maintenance or weather, the cargo perished, and the company was liable for the damages. We were operating on shoestring budget as it was. So this organizational factor created a hazard of putting undue pressure on the pilots to fly in adverse conditions that may be unsafe. Those are the sorts of things that we're looking at. In like manner to the system perspective, at a lower level we look at the failure perspective. With each of the system elements that we learned about in a previous lesson, with each of the system elements, we ask what hazards might be present as a result of each element. Is our hardware subject to fatigue, cracking, breaking? Is there redundancy to protect the system if it does break? Are procedures adequate? Concise, clear, appropriate to the job at hand? What hazards might be present as a result of each element? Finally, there are many hazard recognition factors that we can use to root out and identify hazards. Look for hazard sources. energy, fuel, hazmat, etc. Use industry hazard checklists as aids to trigger our thought process and hazard identification. Some sample checklists are in the back of your book. Lessons learned from previous industry practices, legal and industry-specific safety criteria. All this can provide clues into what hazards may have generated these standard practices. The use of key failure state questions is a very good method to identify hazards. A list of questions is provided in your PowerPoint. Identify top-level mishaps, safety critical functions, by the use of a system mishap model. Work backwards to hazards and hazard causal factors that would provide the path from the hazard to the mishap, as well as the hazard triangle. The hazard source, the initiating mechanism, and the target or the threat outcome. We're going to talk more about the system mishap model, top-level mishaps, and safety critical functions in the next presentation. All of this information should be logically and systematically reviewed in order to provide thorough analysis of the system to ensure all hazards are identified.